In class, when we ran into number 9, we were reading it and we figured out this is a typo, right? So I gave up on this guy, but I figured out that this actually has 2 questions combined. So do me a favor and erase like part from a radioactive substance. We're gonna make a whole good problem out of this, okay? I just recorded a second video on like the second part of the video of this problem, but I want to now and save this one. All right, I'm gonna read this and I have to like give you some more information about this. The function a of x equals a naught times e raised to the negative 0.0032x models the amount in pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material was put into the vault. If 525 pounds of the material are placed in the vault, how much time will need to... Now, here's the thing. We don't have the rest of the question, right? So I will make it up and I will give you the problem, okay? How do we word this? How much time will need to pass for only... I'm going to make up a random number, okay? I'm going to get a random number of 225 pounds, completely random, to remain. Now we have a whole question that we can answer, okay? So let's try this. We begin with how much? 525 pounds. So that's the initial amount. I want to know when I will have 225 pounds, okay? So here we're looking for x, okay? I usually use the letter t, but x in this case is the number of years since the material was put into the vault. So let's plug it into our a equals a naught times e raised to the negative 0.0032x equation that they gave us, okay? All these given that we got, okay? I'll put 225 on this side. I'll put 525 on this side. And I'll bring that exponential term down. All right, we're solving for x now. What do you do to both sides to get us started? Divide both sides by 525. I try to pick a nice number because I didn't want to get an ugly decimal in the middle of a problem, but let's see how good I was. All right, on the calculator, I'll do a division, okay? 225 divided by 525. Oh gosh, okay. It's not that nice, but it's all right. I'll write that down. The decimal is about 0.428571. I'll just round that much, okay? I'll just do this much, okay? And this equals this exponential term. Just bring this down now. Now, what do you do to both sides to bring that exponent of negative 0.0032x down, okay? And that get rid of that natural exponential. Well, you will take natural log of both sides, okay? You will take natural log of both sides. If you do that, we have natural log of this decimal. And what will happen is this exponent comes straight down to the front and get negative 0.0032x. And you see the leftover natural log of e, that's just 1. So we'll be in like multiplying it by 1. But you know, when you multiply something by 1, it doesn't really change the value. So we can just say that it's gone. Okay? Its effect is gone. Okay. All right. Now we just have to divide both sides by this decimal to have x by itself. 0.0032. So x is this. But what is that in approximate decimal? All right. Let me type this in. Natural log of 0.428571 divided by negative 0.0032. All right, wow, okay, it's going to take a long time. 225 65 years. You know what, I'll try to 4.78 years. Okay. Or I should be careful, was the time in years or was it in month or what? Let me go back and check it. Yes, it was in years. X was in number of years. So the answer to the question that I just made up is gonna be that. So I was trying to give you at least like a couple more word problem review. So question 9, when we did this in class, we had a typo, so I just didn't do it. But now you saw two different problems on exponential growth or decay function.